So I'm very honored to introduce our next keynote speaker. Today's theme seems to be the former PhD Advisor Day theme. Our speaker earlier was Dennis's PhD advisor. Our next speaker was my PhD advisor. And other than that monumental achievement, that challenge perhaps is the better word. Jim has done so much in the field. He's currently a Curator's Distinguished Professor of Computer Engineering and Computer Science at University of Missouri, Professor Emeritus. So now he gets to live the freewheeling life of doing research whenever he wants to, the dream. He's been the president of the IEEE Computational Intelligence Society. He's won the Pioneer Award for Fuzzy Sets and Fuzzy Systems to the Computational Intelligence Society, the Meritorious Service Award. He's a fellow of the IEEE and a fellow of the International Fuzzy Sets Association, and has won the IEEE Frank Rosenblatt Field Medal, which is IEEE's highest honor in the area of, is it artificial intelligence? Or?
No, that's just this one.
Yeah, right. So, without further ado, I'm very honored to introduce Jim Keller.
So thanks, Tim, and everybody. So I don't like to have like the title slide when I start the presentation. And this is about from my three of those are from my last visit up here. I think I was trying to point at the level of snow that was in, I think that was 2018 when I was here. And middle picture is a couple of distinguished professors here at Michigan Tech celebrating Talk Like a Pirate Day back in the former times. We did a serious celebration of that particular international holiday back in 20. Anyway, this used to work. Oh, there we go. So instead of trying to put together talk about streaming data analytics or fuzzy systems in engineering or something like that, or in nursing, I happened to be invited a few years ago, last year, when I was president of the IEEE Computational Intelligence Society, to a celebration of John von Neumann's 120th birthday. And of course, he wasn't there. I don't know why. But it was in Budapest, and it was at the Hungarian Academy of Sciences. We shouldn't do that. And this was the invitation. So it was in September of last year, and and so we have a chapter in Hungary of our society, and so they were involved in this, and so I got invited, and I'm thinking, what am I going to talk about? They said, well, you should talk about something where John von Neumann's work influenced your work. And then I was really stunned because I'm thinking, oh my gosh, what do I know about this guy? And so if you go out to Wikipedia and you say, tell me about John von Neumann, and so they list some of the facts, like where he got his degrees and that, and then they have this known for. And I think Albert Einstein has like 13 things. Right? John von Neumann has this list plus 93 more. It's startling the topics that he was involved in, that he was in foundations of. And if you look at the fields, he did everything from basic set theory, made very fundamental contributions in basic set theory, and many other branches of mathematics, physics, pure and applied physics. He was an engineer. He worked worked on a Manhattan Project during World War II, you know, and actually probably was one of the key factors for that, for the success of that. I mean, politics aside, you know, and you know, I really like to look at his academic advisor list. You know, includes like David Hilbert, you know, I mean, among others. I mean, just look at the list, and it's a great pedigree. This guy basically knew everything. You know, what did I know about him? You know, it's like, well, other than when I took my first computer class and the professor got up and said, well, you know, we're working on von Neumann architecture computers. You know, the idea of the stored program, you know, and executing instructions. And, you know, and I thought, okay, well, that's not going to help me a whole lot. Other than, well, yeah, I work on computers too, you know, kind of thing. So I thought, well, you know, I know von Neumann's stuff was in there somewhere. So when I was studying for my PhD, I had to demonstrate proficiency in 2 foreign languages. You know, I took a lot of French, so that was okay. So it was enough to be able to read mathematics in some other language for the second one. So I chose German because I was in the math library looking around and I found this math book of John von Neumann's in German and an English copy of it right next to it. And so I studied John von Neumann, but not his work. I studied his words, you know, translating back and forth, so enough for me to pass that test. So anyway, that was my connection to John von Neumann. You know, so I thought, well, okay, I was the president of CIS, and so, you know, the buzz today and the buzz in this room today is AI, right? Everything AI. We're gonna celebrate the start of an AI center here. You know, it stemmed out of last year's activity in this particular thing, and so, you know, I thought, well, maybe it would be good to look at the distinction between artificial intelligence and computational intelligence, and suppose I was representing Computational Intelligence Society. So I started doing a lot of reading. So this is really kind of a history talk. And I think that you know, it's advantageous sometimes to take a step back and to see, you know, where we came from as we blast forward into the future, you know, of AI. And so I started reading about John von Neumann, and you can't not consider Alan Turing because they intersected with each other, and they both are very connected to artificial intelligence timeline, right? And then I thought, well, you know, if that's the case, how do these large media models fit into the equation? You know, that, you know, how would they have reacted to that? So I'm going to tell you what I believe their reaction would be to ChatGPT or to any of the large media models. It's all pure speculation on my part because obviously that wasn't around till recently. And it's just sort of streaming consciousness, you know, in this, generated by just reading everything I could find about these two guys and my own interpretation of it. So, you know, is it really a big deal to say, you know, I'm in the Computational Intelligence Society and not the AI Society, which of course there is none in IEEE. And it sort of depends on who you ask this question to and when you ask the question. And that's, if you see, that's John von Neumann back in the background there giving me this. This is at the Princeton Advanced Study Institute, where he was there with Einstein and these other guys, you know, studying. Supposedly they were just being creative. You know, they were brought together to be creative and you know, and to interact with each other. So one of the maybe unpleasant duties of being the president of a society is that you have to end up writing editorials in the magazine. So in the Computational Intelligence magazine, one of them I looked at, you know, this idea of what's in a name. You know, like what's the difference between computational intelligence and artificial intelligence because we all want to know about how AI is going to help us, right? Or what are the dangers of AI? You know, and so I thought, you know, it'd be good to look at this. And our keynote speakers, the previous keynote speakers, have all been focused on that. How is AI helping, right, in this regard? And I stepped back and I said, well, what is it? You know, what is AI really? And when I was a kid, you know, and I was first asked to teach a course on AI. And I was brought into the department and they said, hey, we got this course on the books AI. Here, I want you to teach it. You know, and so I started looking, and I knew what it was. They were systems of propositions, logic propositions with discrete symbols. Right? You use first-order predicate calculus to manipulate these things, and then maybe you threw a little probability theory on the side. Right? You know, it's like if you think about the early expert systems like Mycin, you know, diagnostic systems. They were crisp rules, you know, symbolic rules, and the rules had probability associated with them somehow. And then when you did a chain of inference, you would multiply probabilities together and get the probability 10 to the minus 6 by the time you multiplied all those little tiny numbers together, you know, of the conclusion. You know, and that's kind of what I had in my mind. And of course, there were languages. You know, if you're old enough to remember Lisp or Prolog, you know, they were languages devoted to symbolic manipulation, right? And there were machines that were created to in hardware implement Lisp. You know, we had a couple of them. I mean, they were, you know, these gigantic, you know, laptops. I mean, you know that, you know, probably cost us $70,000 each. You know, that your phone is more powerful than now. But I mean, it was a thing. You know, it was all about creating these systems of rules. So, Computational Intelligence Society started out in IEEE. There's a structure called a council. There are societies and there are councils. And what happens is when a new technology comes around that multiple existing societies are interested in, they form a council and they all have input to it. So that's what happened with neural networks back in the 80s. Right? They said, ooh, you know, the Computer Society was interested, System of Cybernetics, the Signal Processing Society, Control System Society. A lot of people wanted to get in on this new thing, this neural networks. And so after a while, once you get, if you're a council, and once you get some transactions and you get, you know, conferences and you know, you develop a certain, you know, kind of forward push, you turn into a society. And so back right around the 1990, I think, or so, we became the Neural Network Society because politically it's much easier to just take the word council off and put society there than to say, oh, I also want to change its name. And then once we got that settled, then a year or so later, we went through the process of becoming the Computational Intelligence Society. It would have been nice if we could have been the AI Society, but that was a non-starter. Because the Computer Society has PAMI, and they would never have gone through. So we became, but it was okay for me, because I said, oh, they're different because the AI is based in symbolic processing, and computational intelligence was all about representation of these ideas using numeric models, numeric and functional models. So there was a split. So in my mind, it was a nice crisp partition, you know, at that time. And so the pillars, these were the pillars of the Computational Intelligence Society. There's neural networks, obviously, because we came from the Neural Networks Council, fuzzy systems, and evolutionary computation. And there's a whole bunch of other topics that have evolved within the society. For example, artificial life, which we'll come across in a little bit. is also, in our sort of field of interest, right? And several other things, games and many other things, AI and games. But was it really a nice, crisp partition, right? So I went back, I thought about that for a while, and I went back to the place where AI got its name, right? So in 1955, John McCarthy, Claude Shannon, and some others wrote a proposal to NIH to have this conference in Dartmouth in the summer of 56, where they coined the term artificial intelligence. And the thing that they said was that AI, the definition it gave in the proposal, was that AI was a science and engineering of making intelligent systems. A nice circular definition. But that's what they said. But if you read the proposal and you look at the minutes or whatever that came out of the report that came out of the Dartmouth conference, this new fledgling area back then called neuron networks was added into this thing. So back in 1955 or 56, they already decided that somehow neural networks has something to do with AI. Right? So that shattered me, of course, because I was hoping that you'd make this nice crisp break. And so the partition was never crisp, and Tim will know what I mean by this statement. It wasn't even fuzzy, where you share, neural networks of 50% AI and 50% CI, right? They're in both. I mean, it's the same, and so it's more possibilistic than fuzzy, right? And other things, like, for example, fuzzy systems. Are they only computational intelligence? Well, if you think about explainable AI, fuzzy rule-based systems play a definite role there. There's not this nice, crisp way to distinguish. So we had president, a couple before me, who thought, oh, I know what I'll do. I'll go make a survey. That's always a great thing, right? Go ahead. Send a survey out to the members and see what they think about it. And of course, the survey came back with essentially a uniform distribution of all possible ways. One subsumes the other. They're disjoint. They're completely the same. They have some overlap. So you can draw any Venn diagram you want, and some subset of the members of the Computational Intelligence Society said that's the way AI and CI are. And so my position in that editorial and in my life is that you shouldn't get too hung up on the words, right? I mean, it's not a dichotomy, and just do what makes sense in here. And of course, we are the Computational Intelligence Society by AAA, but we're really the AI Society. We're the Society of AI. But we share that with other sister organizations within IEEE. There's now a new transactions on artificial intelligence that's co-sponsored by us, the Computer Society, Signal Processing Society, System Managed Cybernetics, and Robotics and Automation. It's a joint ownership, and we have good relationships with those. And also there is a conference on AI. This year's edition, so the first was in Santa Clara 2 years ago. Then this year was in Singapore, and in 2025 they'll be back in Santa Clara, and I think the Computer Society is going to be the lead that year. It'd be a great place for the Center on AI to have representation, right, in both of those venues. Right? So I'm feeling pretty good, Hey, I got this figured out, And then I found out why only go back to 1956? Here's von Neumann and Turing asking me that question. And so you go back to Alan Turing's classic paper where he asked the questions, can machines think? And it hit me that Marcus, yesterday, exactly, he said, he slides, I was looking at it, I couldn't read any of the slides because he had way too much stuff on them, but he had these little phrases that would say, now I tell it to think for a while, right? Something like that, you know, like, don't make a decision too quick, you know, go back and think about it. Actually, we love that, Tim and I love that, that's the principle of least commitment, right? And so, that's a famous computer vision principle, actually, David Marr. And so Turing, in that paper, which is a great paper for everybody in the Center for AI to read, because he essentially goes through a list or he doesn't actually really answer the question, but he goes through a list of arguments of what people will say to say they can't. And then he gives rebuttals to these things. And it's just really a fascinating read from, you know, if you go back and put yourself in the mindset of 1950, you know, this is right after World War II, you know, Alan Turing had left, actually was at Princeton with von Neumann, and von Neumann wanted to give him a job there, and it was right at the beginning of World War II, and so he said, no, I got to go back to England to help in the war effort. Of course, he's probably the biggest hero, you know, World War II hero from the British, you know, because he broke the Enigma code. But he was sure it was going to happen, you know. And he said, you know, and he's famous for this idea of the Turing machine, right? The single machine that can compute any computable sequence. And so his quote was, it's just a matter of time. It's going to happen, you know. It's just programming. You know, just, you got enough programmers, you got enough time, you're going to be able to really create a thinking machine, was his belief. But the interesting thing to me, being in the Computational Intelligence Society, was that his idea was essentially machine learning. Because what he said is you construct, think of it, you have to construct like a child's brain, right? Like an open notebook, right? And then you start filling it up with experience, right? And so, you know, and he said you need to be more efficient than just reward punishment. You know, like that, you know, the put your hand on the stove and you pull it back kind of thing. You know, you got to be deeper than that. And so you need intuition. And you know, in today's lingo, we'd all say that's sort of like transfer learning, right? You know, because what we're trying to do is we're trying to say, you know, take this thing and, you know, where you really know what's going on and pull it over into your current problem domain, right? Transfer it over and make it work. So back in 1950, he was thinking about that. But he never actually worked it out because, of course, he had very primitive computing capabilities. So it was mostly a thought exercise. And so he said, well, okay, look, here's the problem. Is that if I'm going to think about whether machines can think, both the word machine and think, I don't have a definition for it. You know, I go through a little bit of argument about what can you consider a machine? You know, and so I'd rather get into that. But he said, because I can't really define these things, I'm going to replace it by the imitation game. I'm going to say this. I'm going to create a test for that. And we've all sort of heard. We've all watched the movie, right? The imitation game. And we've all heard of it. Even I had heard of it. You know, and so this was his statement of it. Can a machine imitate a human well enough to fool an interrogator, where the average interrogator has at most a 70% chance of giving the correct IDing the machine in a conversation, you know, and he also said, you know, and in 50 years, he said, this is 1950, and in 50 years, it's going to be possible as long as we have a storage capacity of 10 to the 9th. He didn't say 10 to the 9th what? 10 to the 9th, right? And where did he get that number? I mean, 10 to the ninth. It just said, if you have 10 to the ninth, it's going to be possible to have a thinking machine. And so this is kind of the standard setup of the imitation game, is you have the machine and the human, blocked off by the interrogator. From the interrogator asks questions, and one of the two will answer, and the interrogator has to decide whether or not it's the machine or if it's the person. Right? This is my favorite version of it here. Don't be nervous. My parents just want to find out if you're a good human being, a decent human being, and then, and that's the answer. I think that would fool me if my daughter brought this lady. So how can we tell? Well, people have been worrying about this problem. I mean, some people just decide it's just there. These things can think, and so let's just let them think. But it's a little deeper question than that. Now, by Neumann, I could not find anything that he wrote where he actually would say whether or not he believed that it would think or not. He didn't give a recipe, and that's, of course, von Neumann is very engineering oriented. Right? He's mathematical, bottom-up kind of guy, as opposed to the deep thinking from up on top. And so he didn't say anything about the imitation game, and it's probably because they split right before World War II, at the end of the 1930s. They split and went their separate ways. As do most current researchers, right? So there have been lots of work done where people have been interviewed about this particular question, and so there's the ones that say, well, the things that it can do are so amazing that these large language models can do that it's sort of, I see that glimmer of thinking in there, and the others are much more cautious to attach intelligence to that interaction. And there was actually a prize that was sponsored by this guy, Mr. Loebner, for for building a machine that could win the imitation game. And unfortunately, he died, and the money in his endowment ran out in 2019, which of course is right about the time ChatGPT shows up, right? So it's right before that the Loebner Prize stopped being given. And, I'm sure it can fool many people in a short conversation. So this paper down here, they had, 1.5 million people played a version of this, and the large language model was prompted to respond like a human. So it took out the phrases where it said, well, I'm really just a machine, so I can't really, blah, 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 So it actually was prompted that, and it fooled most of the people, right? I mean, you can trick it. I mean, you can increase the odds by, if you know something about it, like you can ask it some math questions and things that, it's not going to do well on it. It's well documented that these things hallucinate about. But that's like using deceit as a goal for trying to decide if you're intelligent. If you can fool me, you must be intelligent. I don't know. That seems unsatisfying. It's like a parlor trick. So I thought, well, why don't I just ask ChatGPT? Right? So I started to say, what does it think about it, whether it can pass the test? Of course, I had to cross that out because I'm not sure if that's true or not. So I asked it, could you pass the imitation game, Turing's imitation game? And the first thing it did, of course, is it defined what the Turing test was, right? But then it's kind of interesting, the answer. It says, well, it's challenging and debated, and heavily debated milestone, whether, that's a way to tell whether I'm thinking. And that, hey, I am an AI model, advanced AI model, but, I probably can't do it because I can't carry on real-time conversations, you know. But then, of course, it ends by saying, but hey, I can tell you a whole bunch of stuff. So, you know, why don't you ask me some questions? You know, I'm ready for you. You know, so it didn't want to commit. And so, you know, it leads to this idea of, do we think the AI is going to generate enough thought that it can become either a force for good or have the AI apocalypse, right? You know, Skynet going to show up, you know, and so IEEE Spectrum had an interesting article, and where they interviewed these experts, you know, AI experts, and they asked them to put themselves on this graph. And so at the bottom of the graph is low probability of artificial general intelligence, right? You know, actually thinking kind of intelligence. Top of the graph is high probability of that. And if you look at the other axis, though, this is clearly not a math axis, right? It's like the left-hand rule or something, you know? It's like low probability is over on the right-hand side, and high probability of a disaster is on the left-hand side. You know, so it's kind of reverse. But you can see these people split themselves apart. So, you know, down in this lower corner, you've got the people who don't think you're really going to get general intelligence in the near term, for sure, and that even if you did, it's probably not going to hurt you, right? That's sort of, right, that's that group. But there's a few people up in the upper corner over there that are worried, right? And of course, there's some people that are splitting, like Bengio. He's kind of like put himself right on the line, you know, kind of straddling the line. Jeffrey Hinton's up there somewhere. Yeah, he's up in that quadrant. You know, and of course the article talks about what they said, you know, and why they put that in there. But it's interesting. Of course, it could be that when they put their faces on this chart, they were interpreting the axes the way we would normally interpret axes, and so maybe it's completely reversed. I don't know. You know, it's hard to say. But anyway, so this is kind of my summary of that, is that, you know, what is ChatGPT? If it looked in a mirror, what would it see? Right? And this is just my belief. It's just a reflection of us, because it's taken all the stuff that we do and it's amalgamating it, and then it's, you know, with the rules, it's spitting it sort of back out in some other order, right? You know, being able to answer the questions. Now, it can answer great questions and that, but it's really, in my mind, it's just a reflection of humans. And I used DALL-E and a couple of other large media models, and they didn't pass my test because I didn't get this image out of any of them, right? Actually, this was my prompt. Since I was going out to DALL-E, I wanted a DALL-E style painting of an AI robot looking in a mirror, seeing a reflection of people. I mean, that seems pretty explicit, you know? But I could not get anything close to that out of any of these. So I just went to the is AI art session, you know, which was really interesting. But I mean, that's just kind of the question, you know, that is, I mean, this looks kind of artsy to me, but it doesn't, I don't think it's really art, you know? So the way I had to do it is I had to use several different kinds of prompts, and then I used Photoshop and PowerPoint to put this particular slide together, you know. But so I'm going to say it didn't pass my test, right? And so people have now gone to saying, well, what are some other ways that we can assess whether or not these programs are actually able to produce thinking, you know? And so analogy tests pop up. You know, this paper down here from 2019, they said, you know, you got these, see if they can generalize. So, you know, each of the top column, each column is a training point and a test point. So it's, you see the transition from, the first block to the second, and then you show it the first block, and you ask what should the second be, right? And so it's different ways of saying, oh, well, you got to get rid of the things that aren't solid objects, aren't rectangles in the first column, right? So you would have to get rid of, in the downward one, you'd have to get rid of the things that weren't, rectangular perimeters. Right? That would be, and humans seem to do much better on that than the large language models that were sort of tuned to processing images. So Alan Turing was a big proponent of thinking machines, right? And from very high level, although he did have his roots in, he did realize that you're going to have to do some kind of learning, machine learning to do this. And so there's the famous book by von Neumann that was published after his death, on computer and the brain, which came out of some lectures I believe he gave at Yale while he was actually dying. I mean, he knew he was dying, so he was frantically trying to get this stuff done. And so what he tried to do is go the other way, go from the bottom up. So let's see if we can model the nervous system, right? And then from there start getting these properties on there. And so he said, hey, I'm going to treat it the way a mathematician would treat it, and it's systematic speculation, right? It's just I'm speculating about this. And so he was more cautious. So he thought, well, rather than tackle the big problem, let's tackle them one by one and come up the path towards a machine intelligence. And so he said his most immediate observation looking at the nervous system is that it's actually digital, the nervous system. Things fire, at some point, right? But they're connected to an analog inputs and stuff. So he said that, you've got this digitally organized nervous system, neurons, because the McCulloch-Pitts neuron had been introduced at that time. But in order to process the complexity of existence, you have to have either an analog or at least some kind of a mixed role in the nervous system. And so, he said, you got this problem. You got this very high precision in artificial automata and low precision in the nervous system. So that's why, there's got to be some kind of duality between the analog circuits and the digital circuits in there. And the nervous system, he says, highly stable. I don't know. I may be a contradiction to that. Yeah. Okay. So, and these are all quotes out of this book that he's saying, he's just puzzling over this, right? That, by the way, that's him. I forget who the other guy is. That with one of the early. You think that's Shannon? I didn't. Well, maybe I guess it could be. So, he says, here's the problem with the computer, is that human evolution handles loads of uncertain and ambiguous information, right? And he was really puzzled by that. And so he said, somehow we got to rectify that anomaly. And so he said, let's keep digging down, right? So he realized, because by the way, he proved one of the Gödel inconsistency theorems in parallel with Gödel. Gödel, he wrote to Gödel and he said, hey, I've got a great, extension of what you published. And Gödel wrote back and said, yeah, I know that too. I've tried that trick with Tim. It just doesn't work, But anyway, he was very, very concerned about these kinds of things, whereas Turing was just sort of saying, yeah, it's just a matter of programming, You know, give me enough coders and enough time and 10 to the ninth, you know, and I'll get it done. I mean, he was convinced of that. You know, so, you know, he makes a big point in this book about a visual analogy with triangles. He said, you know, if you show people, if you try and explain what a triangle is, and you show people pictures of triangles, of images where the lines aren't quite straight, they're a little wiggly, got a little noise in them, maybe the angles don't quite add up right, people would still be able to say, yeah, that's like a triangle. You know, and he was just struck by the fact that in order to encode all of that information, and particularly symbolically, you can't do it, right? And so he's saying there's got to be something else. You can't just deal with symbols. And so, of course, being a physicist, he said, well, you know, thermodynamics, the probability of thermodynamics is a way to handle uncertainty in that. So maybe that's how the brain works, is that it's assigning, and we can make machines better by having them be able to handle uncertainty rather than just you know, have to encode every possible combination. Blah, blah, blah. So he's got this thing about, he's got a lot of stuff about probability, and I read this paper, and of course I wasn't really enthused by it, because I think that, you know, this particular paper said, well, you know, that line of reasoning is sort of, you know, kind of presaging Bayesian networks. You know, and of course I would think it's more like a pre-staged fuzzy systems, right? You know, but some way of handling uncertainty in dealing with complex situations. And of course, he was the inventor of the self-replicating automata. Right? So he had these self-replicating automata. Again, it was a paper exercise for him. Right? And it's sort of it's a machine that can, he said, if you're going to have intelligence, you have to have a machine that has components that can replicate themselves in the process so that you can keep getting more complex. Right? He's saying, you know, that's the only way to do that, is to have that. And, you know, he didn't get to the next step, which would have been, you know, simulating evolution. I mean, but this is evolutionary computation in here. You know, artificial life is kind of what he was talking about. And, you know, this idea that he came up with predates the DNA structure discovery by 5 years, you know, by Watson and Crick. Because he said the automata has to have 3 things in it. It's got to have the functional part, right? That's the operating part. It has to have a decoding mechanism that can take instructions and produce the functioning part. And it has to have a way to copy that part onto the other thing. Copy this. So that you have a complete copy. And that's, of course, what DNA is, right? And I don't remember whether it was Watson or Crick, you know, said, hey, without von Neumann, we would have never figured this out. You know, I mean, it's like, you know, I'm getting this hammer hit on my head every time I, you know, read another page in here, you know, because I was saying, what does von Neumann have to do with me, you know? So, here's what I think about these two guys. You know, probably Turing would be more like the grandfather of AI, you know, because he really was there first, and you know, and von Neumann the father, or they're both the fathers, or the great uncles, or something. But Turing was a top-down, believed in artificial intelligence happening mostly symbolically, and von Neumann bottom up. He was took more of an engineering approach. And so I'd hook von Neumann up with computational intelligence. He did neural networks. He did, well, I'm going to tell you that in a minute. Yeah, so he pioneered both biological and artificial neural network theory, right in here. He worked on cellular automata and the idea of artificial life. So that's kind of evolutionary computation, again, one of our pillars. And he understood and he proposed models to handle uncertainty in representation of knowledge. Because he used thermodynamic probabilities, but he predated the definition of fuzzy sets. So, would he have done it? I'm going to say yes because it's my talk. And this idea of the digital analog combination, the mixed role, that's exactly what, consistent with fuzzy set theory, or fuzzy systems, not fuzzy set theory per se. You've got these analog-like confidence values that you build up over time, and then when you have to make a decision, you harden them, right? Because you have to make a decision, and you have to say, okay, now I'm gonna go this way or that way, and so it fits nicely, I think, because many times you want that digital answer, the discrete answer. Sometimes you're willing to say, maybe you just want the confidence itself and let somebody else interpret it. So what do I think they would think about ChatGPT if they were around today? Well, here's my thing. I think Alan Turing would have said, "Go for it, baby. You got it." This is much like Marcus. I'm speaking to his talk, but I think that von Neumann would say, yeah, maybe. If you look at Shankar's talk, I was looking at it through this lens. He used a lot of traditional machine learning kinds of concepts in dimensionality reduction and even some of the used it in recognition and that, and then he's moving towards integrating in the large language model stuff. So he's more on that side. All right? So of course my question to you all is, what do you think? I don't know. This is just me. So do you disagree with my conclusions? Well, don't blame me. The reason is because this whole talk was made up by ChatGPT. Well, not really. Okay, so I'm finally done. I want to thank I want to thank ICC, Tim, and the College of Computing, Dennis, and everybody else for letting me come and ramble. And of course, many thanks to all of you. This also came out of, I'm not sure where I got this robot from, but one of these large media models. So, thank you. It's actually really hard to stand right here and when it's projecting up here. I'm a wandering kind of guy, but I thought, well, if you're recording, I should probably stay close to the microphone somewhere, because it's hard for me to read this. So that's my other excuse. If I said something stupid, it's because I just didn't read it right. Okay.
Jim, I really enjoyed your talk. It was a lot of fun. So I'm trained as a chemist.
Yeah.
So I'm trained as a chemist, and there's a couple of thoughts here that were going through my mind, and I'll just sort of toss them out and let you comment if you want. One is, and I don't know if it's an apocryphal story, if it's actually true, when Shannon was working on his information theory and he didn't know what to call it, he was talking to von Neumann about it, and it was von Neumann's suggestion to call it entropy because no one knew what entropy was, and that was a broadening of that concept, which is a story that I've heard in physics circles many times. And it may or may not be true, but it's a good story nonetheless. Then the other thing is on Watson Crick's paper in '53. The paper is about 2 pages long, goes through all of Rosalind's X-ray data and proposes the structure for BDNA. And it's not until the last 2 sentences of that paper where you get the greatest scientific understatement of all time, where they say something along the lines of, it has not gone without our notice that the model that we're proposing here, because it's all about the chemical model,
Yeah.
explains how biological replication can occur. I mean, so the whole paper is not trying to describe DNA as the genetic material and how replication happens. It's all about the physical properties of the model, and then they just sort of leave that there dangling.
Wow.
And that was an arm wrestling between Crick, who was, much more English and much more understated, and Watson, the gregarious American, who was willing to claim it, go a lot further. And that's where they negotiated to settle on that.
Well, I wish I had a paper like that. That's why I'm not really a history guy, but I found this to be just intriguing to take a step away from what I do normally to look at the underpinnings of what we're doing now. Yes, sir. Ian.
You've gave a great talk here about machines thinking and machine intelligence. Do you have any thoughts or speculations on the even deeper or heavier question of machine consciousness?
Yeah, I don't believe it, personally. I mean, if you're asking me, will we get the singularity event happening? I just don't think so. I mean, but who am I? I'm just one guy, If a Terminator shows up at my house, hopefully it won't happen until after I'm gone. But but I don't think so. That's why my thought was about the reflection. I mean, I don't know. How many people think that we're going to get consciousness in machines? Anybody? Okay, we got a few bold, couple of bold, three, yeah. And one wavy math guy, Yeah, I don't know. I just, I mean, who's to say? And that's one of, if you look at Turing's 1950 paper, they actually, one of the arguments that he rebuts is this idea that God made humans intelligent, and so, and they have consciousness, but you can't, and so hence you can't have a machine that does it. And so then he tries to make an argument against that, against that particular stand. So, I guess it's possible. I just don't see it. We have a question here in the back. Somebody with the microphone.
Maybe I don't. They talk about the death of expertise. Like, where is expertise at risk, in your opinion?
Yeah, I think so. I mean, I think that's what happened. I guess I should go back here. I think that was what I saw at that session on Is AI Art? And it just struck me that, when I go to, like, when I went to the Van Gogh Museum, and you read the descriptions of particular masterpieces, and they talk about the play of light and the color, and how that, and the brush stroke, and, and they have all that things that he developed, and you look at, he has like 12 versions of the same painting, right, building up to the one he really, that you normally see. And so that, I think that's, we're all losing little pieces so far, right, of what we used to be able to do. Like, how many telephone numbers do you know by heart, or, in your head? Probably not too many. I mean, I can remember when I was a kid, I knew 100. I could probably spout off 100 telephone numbers of people that, I knew or family. But of course, we replaced that with something else. So it's not like we just lose something and then we're done, and our brain is dumber than it used to be. I think that, as long as we can find the substitute for it. But I think there's, at some point, it really is, we're going to just give up a lot of what I think it is to be human, to let these machines think for us. Think. I don't like to use that word, but You know, although I'll tell you, you know, now since I've reached a certain age, you know, one of the likely occupations, if you don't want to just sit on the couch at home, is, you know, greeter at Walmart, right? You know, hey, welcome, come on in, you know. Go down to aisle 5, there's a great sale. But I was reading in the paper that these companies like OpenAI and others are actually hiring human trainers, experts now, to train the AI. So for a short time, there's still a lucrative enterprise that we can all get into of being AI trainers. I mean, this buddy of mine, the guy who was the founding editor of Transactions on AI, Hussein Abbas in Australia, he was always pushing, and for a while I didn't really understand what he was talking about. He was pushing for an AI university, but that meant a university for the AI, you know, to teach it how to be ethical, to teach it how to be, you know, to not hallucinate, you know, and blah, 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 and a bunch of other things. And so I think that's, you know, if there's enough focus on that, then I think we're, you know, at least we got a hope. But I do, you know, I do worry personally.
I have a conjecture about 10 to the 9th.
Yeah, okay.
Roughly of the order of neurons in the brain, sort of up there. And if you think about the Babbage engine, and it has the store, and it has they're like these discs or something like that.
Yeah.
Maybe he's thinking about a Babbage.
Well, I'm
style
sure
engine, and
he
it
had
could
a
be 10
reason. I
if
was
you had
just
10
trying to
the
make
9th
light
those,
of it.
I'm thinking maybe 10 to the 9th of those would probably like be a simple model of something like a brain, maybe, or something.
Yeah, and I'm clearly doing Alan Turing, a genius, a disservice by kind of laughing at 10 to the 9th what.
There's no units yet.
Right, 10 to the 9th what, you know. But he had it. He probably knew what 10 to the 9th of something that he was working on. But I couldn't find it, you know. It was like 10 to the 9th memory, you know. I mean, that's kind of what he said. But it could be. I mean, if it is like that, maybe, I don't know, did they know that the brain had 10 to the 9th neurons in 1950?
Oh, I don't know about that.
Yeah. I mean, so the conjecture is sort of like, well, if he were here today, 10 to the 9th might mean that. I don't know. Ooh.
He also writes about ESP in that paper, so maybe he was predicting
Oh,
the
he
future.
does write about
Maybe
ESP.
He was predicting the future
That's
when,
right.
when we know about the number of neurons.
That's right. That's it. Perfect.
Thank you.
He time traveled, too.
Thank you.
We done, Tim?
I think we're done.
Okay. Thank you so much.